Hi, my name is Paul Lambert from Benchmark PDM, Canada's master Easy-Laser distributor. In this video, I'm going to run through a simple XT horizontal shaft alignment program on the simple pump and motor setup. I'm going to use two different types of XT models to show you some of the differences between them, but the program itself, for the most part, is the same. We'll start with the award-winning XT11 display unit. This thing is a wireless 8-inch glove-enabled touchscreen. It's rugged and it's built to last. It's IP rated 66 and 67 for shockproof, waterproof, and dustproof. It comes with Wi-Fi capability, has 16 hours continuous battery life, and has a 13 megapixel camera included. An accessory option is also the IR camera. So if you wanted to take a thermal image before and after your alignment, you can do so. The measuring units are also IP rated 66 and 67. The first set of measuring units we will use is from the XT440 model. This is the M unit, which will go on the movable side, in this case the motor. The whole unit is actually milled out of an anodized aluminum block, which is another reason why it's so stable when taking measurements, not like some of the other plastic units you see out there. So they come pre-mounted on brackets and rods. They are a dual beam laser system, so you can see the laser aperture at the bottom and the 30mm detector slot at the top. It's actually the same for the other unit, just in reverse. So you've got your locking knobs here for offset adjustment, your angular adjustment wheel here on the top, and a small OLED screen at the top, which includes the inclinometer values and the battery life, which is, by the way, 24 hours continuous. So you can see on the display here, there's many different alignment applications we can work on. Of course, we're only interested in the shaft alignment one and horizontal, but if you wanted to test any of these out, you can download the free XT app and play around with any of these actual programs yourself. So I'm going to go into horizontal. It's giving me the option to continue a previously worked on measurement, or I can go to start new, which I will do. Now it's all 3D graphics. I can move this around depending on where I'm standing. If I want, I can click mirror here at the top in the menu and change my orientation based on where I'm standing. For me, this would be good because my motor's on my left, my pump's on my right. But for you, the viewer, I want you guys to see this and move machines with me, so I'll keep it like that so you can see it. Now the whole alignment process is at the top here in these icons. So right now we're in the preparation and distances stage. If I move along, I would go to the measurement stage, the as found stage, the correction stage where the shimming icon is, and of course the end where the report is. Speaking of reports, if I did want to add any notes, I could go into the menu here, click on notes, and say I saw that the pump was leaking and that's something I wanted to report. I can just simply type that into the notes and that will show up on the report. Now, another nice handy feature is the question mark here in the top left corner of the screen. This is actually the XT manual, ready to help you whenever you need it. It doesn't matter where I am in the alignment process, it will bring up the manual at the stage you're in. So here we are in the preparation stage, and I can make sure I find what I need to know when I need it. I can also access anything I am curious about on the left side of the menu. Or there's also a search bar at the top right corner to access quick information as well. And lastly, before I keep going, I will just go into camera and take an image of the machine setup, as this will go on the report as well. So I can take a photo of the machine setup. And I can also take a photo of some other things, like, for instance, a machine's foot. So now that I've inputted my notes and added a few images, I'm ready to start actually taking some measurements. So I have the first one, S2M, which is my stationary to my movable side. And I'm measuring from rod to rod. I have 7.5 inches. The next distance it's asking for is S to C, which is my stationary to the center of the coupling. It's automatically have that distance, but I know it's actually not quite right in the center, so I will override that and put it at 3.2. it asks you for the RPM. I'm just going to put in the most common RPM, roughly 1800 RPM, because that's going to give us our tolerances later on. The next distance, M to F1, is my movable to foot 1. And just to help me take this measurement, I'll just move the heads down, and I'll go from the center of the bolt hole to the center of the rod, and I've got about 4.5 inches. And lastly, the distance between the first foot and the second foot here, between the motor feet, and I'll put in 5.5. So now that I've inputted all the distances, I'm pretty much ready to move on to the measurement stage, but there are a couple different icons here in the preparation stage that I just wanted to touch base on. On the pump side, I can actually name the pump. I can configure it, so I can actually choose a different machine depending on what I'm actually working on. Now, of course, we're just working on pump, so I will go to pump, put that in there. I can use lock feet or distances, which basically means I can get out of a bolt bound or base bound situation later on when I see the results and I'm trying to move the machine. I would come back here, put the distances in, and basically lock a combination of feet so I can get the optimal move. And of course, thermal growth compensation. If I knew that one of these machines were going to grow at a specific distance or measurement, I could input those values in here and we can align it to that state. Okay. So the exact same features or functions on the pump side are available on the motor side. So I'll just skip that, but I'll go into the tolerances here. The tolerances at the coupling, I can choose different types. I can use the Easy-Laser standard tolerances, or I can go into the ANSI standard tolerances. I can also actually add my own tolerance. Some companies have their own. Thermal growth compensation at the coupling, if I know these numbers, these targets, I can input them. And the coupling diameter, if I want to input the distance of the coupling, it will allow me to view the results as gap and offset versus what we will do, angle and offset. And lastly, the coupling type. Right now we're working on a short flex coupling, but if I wanted to use a spacer shaft, which is actually 2 planes of flexure, I can use that as well. It will change the tolerances, so be wary of this. So I'm now ready to go into the measurement screen. I have a couple things I want to do here before I actually start measuring. One of them is making sure the 2 measured units are looking at each other in this direction here. So you can see by the inclinometers on the top right corner of both of the detector surfaces that I have 5.3 on one measuring head and 5.1 on the other. That would be fantastic and a good place to start because I know they're within 1 degree, which is what we want. The other thing I want to do is make sure the line laser, which is what it comes with on a 440, is right in the center of the detector slot. First, we'll do some adjustment with the heads here. So to start, I want to just move the measuring units to the 0 degrees, which is the 12 o'clock position, just to make it easier on myself. And then I'm going to take the S unit and loosen the locking knobs and just make sure I bring it up to the center of the detector surface. And now moving on to the M unit, I'm just going to use the beam adjustment wheel to make sure the laser beam hits the center of the detector surface on the S unit. Now that I've adjusted the laser beams into the center of each detector, we're pretty much ready to move on with our alignment. I will actually just check the soft foot to make sure there's no gaps under the feet. Now we always suggest using a feeler gauge or shim stock with the feet loose just to make sure there's no gaps the traditional way. But this is more of a laser alignment soft foot check. So, adjust and turn to 12 o'clock. It's already at 12 o'clock. I'll then go to the next stage, measurement stage. Tap any foot to measure. Okay. So we'll start with the one closest to me, foot 4. So I'm going to follow the on-screen instructions, loosen and tighten. Okay, and then I'll go to foot 3. Loosen, tighten. And now foot 2 here. Okay. Lastly, foot 1. Now if I move on to the next screen, it should give me the calculated software result. But anything around 2 thou, we wouldn't normally correct anyways. Okay, now I'm ready to take some alignment measurements. You can see at the bottom of the screen, I have a 0 with a squiggly line. This is the filter. If I had a lot of vibration close by, for instance, and the beam can actually fluctuate if that happens, I can actually up the filter all the way up to 10 seconds if I like. We're in a nice little environment here, so I wouldn't have to, so I'll just keep it at 2. Now beside that, I have 2 measurement methods, easy turn and 9-12-3. 9-12-3 is the clock method, just like any other system. And if you look over top of the motor, I have my 9 o'clock, my 12 o'clock, and my 3 o'clock. And it's nothing other than going to that position and taking your measurements. Now I can go to those positions using easy turn, and I can also go to 40 degrees rotation minimum if I wanted to. So I'll just keep it in easy turn and I'll take some measurements here. So I'll start at the 9 o'clock position, and I know it's at 9 o'clock. With my inclinometers, it will say 90 degrees. And now I can press the green button to take a measurement. Okay, now I'm going to come up to 0 degrees, which is 12 o'clock. And I'll take my second measurement. And finally, I'll come down to 3 o'clock, which will be negative 90. So I have my alignment results here at the top, or in this little table. We have 2 measurements for the vertical plane, the offset and the angular, and 2 measurements for the horizontal plane, the offset and the angular. So I just want to make sure I'm getting the same numbers. So I'm just going to do that exact same procedure using the Easy Turn program, just so I can make sure I'm getting repeatable information. Those numbers are very repeatable, so I'm very happy. In the vertical plane and under the offset, I have 10.4 and 10.7. That's only 0.3 of a thou difference. The rest are very, very close as well. 0.4 of a difference in the horizontal plane. But that's very repeatable. I'd be very happy. If you weren't getting repeatable numbers, there would be some other issue on the machine, whether it's coupling string, bearing play, any number of things, maybe the base, twisted feet, stuff like that. Now that I've shown you the easy turn method on the XT440, I want to bring in the XT770 measuring units, and that way I can show you some of the other measuring methods available, like our continuous sweep and multi-point. So we'll turn these off. Just put them in front here. And bring on the S unit for the pump side and the M unit for the motor side. Now I'll just explain this head again. The XT770 head is slightly different in the fact that it's a dot laser versus a line laser. So the laser aperture is right here, and it throws out a beam to hit the other measuring unit at the target door, and then when we open it, it hits the detector. It has the laser beam adjustment wheels on the corners here to allow me to adjust horizontally and vertically. So it's a dual beam and dual axis laser and detector. So this allows me to do some other things like geometric measurement and thermal growth monitoring. Otherwise, it has the same locking adjustment screws and the same OLED screen at the top. So the first thing I want to do is just turn these 2 measuring units on and let it connect to the display. And you can see at the bottom I have 2 new measuring methods, continuous sweep and multi-point. I could use sweep if I had a lot of backlash coming off a gearbox, for instance. Also if I had a large shaft that once you started it was really hard to stop it. For multi-point, maybe it would be a more critical piece of machine like a turbine, where I'd want to take as many points as possible just so I can get an accurate read. So we'll start with sweep, and I'll just come over here, start, roughly 90 degrees, maybe I'll go 90. Okay, so I'll press the enter button and I'll start sweeping. Okay, press the green button again, and it's giving me the results. You can see it's actually very repeatable with the other numbers as well, so that's very good. So I'll just do that again one more time, just to make sure I'm getting repeatable numbers. Okay, that's great. Very repeatable numbers. Okay, so before I move on, I'll just do one more, but this time I'll show you the multi-point method. So I'll click New Measurement, switch over to multi-point, take my first reading, and now I'll just simply go to different measurement points on the shaft. Okay, I'd leave it there. Again, it's repeating very, very well, so I'd be very happy to move on. All of the measurements I've done, every method I've used, they've repeated very well. Okay, now I'm ready to move on to the next screen, the as found results. You can see the motor is split up into two sides of the screen. You have the vertical plane, and it looks like it's sitting low. I can tell because the numbers at the very bottom of the screen, negative 15.3 and negative 18.3, are the shim it's telling me to add to lift the motor up. At the top of the screen, on the vertical side, we can see the misalignment at the coupling. And based on the RPM that we put in earlier, we can tell that we're out of spec there. Over on the horizontal side, if we look straight down, you can see all 4 feet, and the motor looks like, with the corrections at the feet at the bottom, it's telling me I need to move it 20 thou towards you. And of course, the misalignment at the coupling in the horizontal plane is also out. I can also go and toggle to the table and view all of my alignment results. But at this point, this is just for analyzing the data. Now I need to move on to the actual correction stage. Okay, now that I'm in the adjustment or correction stage, I can actually start to move it live time in the horizontal plane because I've actually left it in the 9 o'clock position. Now, if I wasn't actually right at the 9 o'clock position and I was, say, for instance here, but for some reason I couldn't actually go down, I could choose the wide live adjustment and still move it live time here. Now I could also actually go down to the live 360 mode, which will allow me to simultaneously move it in the vertical or horizontal plane at the same time. For now, we'll just leave it at the narrow, and I'll start to move it up and down, left and right. So in the vertical plane, you can see that I need to add shim to the motor so I can actually correct it and align it. So leaving it in the horizontal plane, I'm going to start adjusting the motor and putting the shim in. So you can see it's actually moved in the horizontal plane after we put our shim in. So I'll keep it live time in the horizontal plane as it is, and I'll come around and it's asking me to move the motor towards me 31 thou in the front and about 40 thou in the back. So I'll start with the back end here, and I'll start pushing it towards myself over here. Make sure the jacking screws are backed off, and then I'll start pushing it. And you can see it actually just start to move and come down. Okay, so that's pretty good there. Now, I don't want to go too much, and I'll go to the front here, and I'm at 13. Push the come down. So it's just come out of alignment roughly, so I'll just make sure it goes back. So after adjusting more and more, I can make sure I'm really good in the horizontal plane. Now all I need to do is retighten the bolts and check the vertical. And now that we're in the live position and everywhere is green, including the vertical and horizontal, I'd be very happy with that result. Now, of course, I would do another measurement just to make sure I'm getting repeatable numbers. But at this point, I'd be happy and I'd go to my report and I'd look at some of the things I've put into this report, including the as found and as left results, my vertical, my horizontal. I can look at the machine setup, the tolerances I use. We didn't put in any thermal growth compensation numbers. Here are my softputs, and there are the photos I took. If I wanted to add some photos, I could take the last couple, select, and make sure they're in the report as well. Okay, now that I have my alignment report, I can do a couple things before I finalize, like choose the template I want to use. If I use advanced, I can go into all the different alignments that I actually did, or the measurements rather. Okay. I can also look at the different notes I made and add any notes I want to finish off. And finally, I get to finalize the measurement, call it whatever I want, click finalize, and then now I have the option to share it. Maybe send a PDF. If I click PDF, I can actually sign it, save the PDF, and email it to anyone I want. And that's how easy it is.